Hello. All right, um last time I want to show you the impulse portion and then we're gonna go into yeah. So first of all, we're gonna go to projectile motion because I added something like this. I'm not sure if it's actually correct. I fixed up a lot of things here. Let me show you what I mean. I forgot the A last time, which was problematic because then the constant is wrong. Well, it doesn't really matter because in the end of the day, there's only two ways a constant can be. It will be either linear, which you can assume to be k v basically, or kv v squared. The reason I chose to do a simple, if you look at the what I chose to do, a simple ball going down, is due to it being one of the few cases where it's possible to predict a projectile motion without doing numerics. So it's not like I didn't want to make a more complicated question about angle and some weird other arc. You can actually get this arc. But what happens here, you have to split it into two, where one half is that way and one half is this way. I believe in this case, this portion over here is only solvable with terminal velocity. Once it goes off of terminal velocity, then it becomes a big problem and a nasty solution comes up. You have to make a reference frame of terminal velocity. What I'm doing here is not doing that, so no terminal velocity needed for it to solve itself. Terminal velocity basically means that in the end of the day, when you get to these equations, you'll see that this one, I believe, because I actually changed the negative over here, it goes like this if I remember correctly. Uh, and then this is a negative direction. So you see how there's a steady state here. And that steady state is going to be used for this portion. Now, similarly, for when it's down over here, when we go over here, when we go to tan H, fun fact, because of how this is formatted, this IC2 could change this to from this state to this state. By having this imaginary. So what that means is that velocity will kind of be like this, honestly, I think, instead of this. Uh, this would imply a positive velocity going upwards. So I was thinking, why does that not work? Why does this 10x keeps on giving me a problem over here? Um, so I was thinking, why does that give me a problem? I realized this constant is the problem. This constant allows me to have it this way, where there's a constant negative velocity in the end of the day when you go to infinite time. Basically is what happens. So another way to look at it is just put an absolute value here and put a negative sign here. Um, it works better that way, honestly. So negative, negative could be like that because this plus c is kind of weird because this function is actually 1 minus x and divided by x minus 1 or something, and you put a negative 1 over here or something with the ln over here and 1/2. This is the actual function of this. So kind of what happens is that there's a plus C in the over here that gets mishmashed everywhere, and then it turns into this format. It's kind of weird. I actually have uh, a solution I like better, but it's less clean. I got that solution. I was like, oh, I like that solution, but unfortunately, it's less clean. So the solution I like is it's a little bit of a wacky one. This is technically correct, but with the constant being boundary conditions that you need to add in, and you have to check that it's going negatively downwards continuously. So the plus C is kind of awkward to use. You'll see how this is basically kind of a nightmare. Uh, basically, this tan either you put a negative sign over here with the tan, or the tan turns to positive because of this, whatever. The way I like to write this actually, it's like a to the division 1 plus e xp plus K2A, something like this, and 1 minus EXP. I didn't do that because it wasn't clean, but you can write it that way. And A is the square root of K1 divided by G or something like that. You can do that. Um, you can do the math on that too. You basically, instead of going all the way to the algebra and doing all that stuff, you stay in this format over here, and you actually make a better format than this. But yeah, you get what I mean. I like that format. I just didn't use that format, unfortunately. Next, we go to this form where we actually just explain to you guys I just use numerics. There's no reason for you to go all the analytical thing and get a pain in the head. This section is really short because I feel like numerics is the way to go in that situation. So I only show basic situations on this one, that one. Because numerics kind of is necessary, and there's no analytical solution that I like personally. Here's another impulse question, but this impulse question is quite simple on purpose. Uh, so we start with basically a same problem on the top, and I just redid that same question because I thought, okay, all right, we'll redo that same question, but without ignoring air resistance. We did that with air resistance. We're doing it without air resistance. And we're basically first showing off PE plus KE, basically obviously easy stuff. We get that K and we're using the same equation again, because we got the same equation for the rebound up situation. And then I'm using this notation, I double prime, because I know I will be in a moment of inertia. So I decided this slash slash will be our way of communicating this, and then we can get this format over here. I might make more impulse question, but I couldn't think of more impulse question. So I was like, oh, I want more impulse questions, dude. I want more, but I can't think of a single more. I can't think of a impulse questions. Oh, I forgot my camera. Um, I can't think of an impulse question that resonates with me with the ability to get without using NV separation, which is kind of like an MAE 30B, which we'll talk about later. And then we did this format, which is an interesting format. I like this format for multiple of reasons. Um, Mainly due to it's just not correct, but it's a fun little flap. You can do this question. It does introduce an integral. It does introduce certain. It just tests you on an integral ability. It isn't something I would the test. It's a bad question. I'll just say it right now. I was thinking of a way to introduce, something, something. Now rethinking about it, it was a bad question. It was an awful question. I don't know why I thought of this question. I do know why, but yeah, it's a bad question. It should have been deleted. But then again, it's an interesting question. It shows that impulse is not just the F average. So I don't know if I should get rid of it or not. Like, it's just give it, and I don't know what to say about it. And yeah, now we're basically in diff. Oh yeah, nonlinear springs. Modeling these are just MATLAB, basically. Uh, so another way to look at this is that this has consistent thickness throughout. This thickness is uniform and is not like this. Basically, if it has some scrunch up point and then uniformity over here, that is nonlinear. Most strings are uniform and therefore linear. Another topic is that they can become unlinear over here, so they just force out here and break. Um, Now over here when they approach D, they can actually come back. And then this is kind of the extension in what I mean. They can come back with a different fold, but they have a weaker tension rate, so they just extend further and further more that you use, even if you use a little bit of it. So next time you go up here, but you're actually extending it too while using it. And continuously this happens, eventually just cross out and then just break the tension. It's just fatigue effect, basically. Not worth it to do that, but Yeah, now I have to do all this stuff. I have to redo all this and make it into something decent like this over here. That's going to be a little bit of a pain in the ass. I don't want to do that, but I will do that soon. Probably not today because I was looking through public domain. What I was trying to do is I was looking for a public domain, like a mass pulley system. I can't, so I have to MATLAB it or I have to actually draw it like this, which will take a while. Uh, this takes a while to do. This looks easy. No, just takes forever to do. I don't like doing it too much because it takes forever, but